Okay, so for this next equation, again, it's set equal to 0 already. All of today's are starting off set equal to 0. So I need to factor the left-hand side. Now I look, is there anything I could divide out both terms by? No. What method of factoring do I use with x squared minus 81? You have to recognize it as a dot. Take the square root of x squared, take the square root of 81, 9. You get x plus 9 times x minus 9 equals 0. And now we could tee that off and set each of those factors equal to 0. And if I minus 9 on both sides, I get x equals negative 9 with the first equation. And I get, if I add 9 to both sides, I get x equals positive 9. Okay, sometimes they would write that as positive negative 9 in the solution set. Again, you do not have to write that. You could graph it and take a look at what that quadratic would look like as well. Okay, we're already set equals to 0, so we don't have to worry about that. I checked to see if I could divide all the terms by something, and I can't. They don't all have an x. There's nothing I could divide 3, 10, and 7 by other than 1. So I have 3 terms. There's a number in front of x squared. So this is going to be your split the middle. Okay? Trinomial, and the number in front of x squared is not 1. That's your leading coefficient, not 1. That's your split the middle. So I get the number I'm going to be multiplying by. I'm having difficulties here. Hold on. I'm going to get the number I have to multiply by doing the first times the last. The middle term it has to add to. Everything's positive, which makes it easier. What multiplies to 21? 1 times 21 and 3 times 7, which also adds to 10, 3 and 7. But this doesn't go straight to the factors. I'm going to bring down the 3x squared, bring down the plus 7 equals 0. When you split the middle, a bunch of you are forgetting that when you write that 3 and the 7, they both get an x. Because these two terms, when you're combining them, will add up to that middle term 10x. So if you just put 3 and 7, 3 plus 7 isn't 10x. You need the 3x plus 7x. Okay, now I'm going to do the factor by grouping. The first group could be divided by they both have the 3. They also both have an x. The lower power is just x by itself. So 3x goes in front. When I divide, I get x plus the 3's cancel and the x's cancel. The 3x divided by 3x is 1. Bring down that sign in the middle. What could I divide both 7x and 7 by? Both by 7. So I have 7 as the GCF. When I divide, I get x plus 7 divided by 7 is 1. So that x plus 1 factor I'm going to write once. Then I have the 3x plus 7 is my other factor, equal to 0. Once we factor, now you have this extra step of setting each of the factors equal to 0 to find the roots. So minusing 1 on both sides, I get x equals negative 1. On the right-hand side, because of this coefficient in front of the x, it's going to be an extra step to solve. I first minus the 7 on both sides, but I have 3x equal to negative 7. Then I have another step of dividing both sides by 3. So x equals negative 7 over 3. If you make it into a decimal, it's going to be a repeating decimal. So I just keep it a fraction. Negative 7 divided by 3. And then I have my negative 7/3, negative 1. You don't have to put it in solution set notation, and it doesn't matter if you don't put the smaller number first. Next one's set equal to 0. Can I divide both these terms by anything? No. I always check for that GCF first. But I have a difference of 2 perfect squares. So I'm going to take the square root of 4x squared. Another mistake you guys are making is you're forgetting to get the square root of the coefficient. The square root of 4 is 2. The square root of x squared is x. Square root of 9 is 3. So I get 2x plus 3 and 2x minus 3. Again, you could always check in the calculator, does this equation match this equation on the graph? So if you guys want to make sure that your factoring is correct, you could put them both in the calculator and make sure they match. Now I have my two factors. Set them each equal to 0, which is going to be two-step equations because there's that number in front of x. The first one, I'm going to minus 3 on both sides first. Get that 2x is equal to negative 3. Divide by 2 on both sides and get x is equal to negative 3 over 2. Add 3 on both sides. Get 2x equal to 3. Divide 2 on both sides. I get 3 over 2. So my solutions are positive and negative 3 over 2. Or you could write negative 3 over 2 comma 3 over 2, or you could just leave it and be finished here. One more. There is no number I could divide all three terms by. It is a trinomial, and this time the leading coefficient is 1. So I can go straight to my factor form, no splitting in the middle necessary like the one above it, because there's no number in front of x squared other than 1. So it has to add to 4 the two numbers, multiply to negative 32. I can put my x's in. Let's make a list of factors of 32, and then we'll consider the signs, but put negative 32 divided by x in the calculator if you're using the table of values. 1 times 32, 2 times 16, 4 times 8. Okay, now one of them is going to be negative, and I'm going to make the smaller number negative since they're adding to a positive. And here's the combo that'll make a sum of positive 4. So it's minus 4, positive 8. But of course the solutions are going to be the exact opposite of that. Because when I set each of these equal to 0 and use the inverse operation to solve, I get x equals 4 and x equals negative 8. So to sum it up, we are doing exactly what we were doing the whole last week with factoring, except now you have that extra step of setting each factor equal to 0. So you have to be able to factor to be successful in this topic. So please contact me if you need any help.